Good morning, Algebra 2. Let's get going. Today we are going to be multiplying and dividing rational expressions. You're going to want to be really good at factoring. And if that's something that you're still struggling with, please talk to me during class. Let's get that fixed. See me for tutorials and we'll work on it. If I'm looking at the numerator here, for example 1, I can factor out 2x squared, and that would leave us with 4x minus 1. Now, a way that you can tell, did I factor out correctly, is by distributing. And if you distribute and you would be left with what you started with, then you did it correctly. So 2x squared times 4x is 8x cubed. And 2x squared times negative 1 is negative 2x squared. Okay, so let's move on. Now, if I factor the denominator, that would leave me with, we could factor out an x. That would also leave me with 4x minus 1. So this is why it's incredibly important to factor, because you got to see if you have matching factors that cancel. Now that we do, let me simplify just a little bit more. 2x squared over x. And truly, the numerator can be factored a little bit more. 2x squared is the same thing as 2x times x, meaning we have a pair of x's that cancel out, and now we have our final answer. Your answer for example 1 is 2x. Example 2. If I factor the numerator, it would factor 2, let's see, x minus 6 times x plus 2. And I'm going to double check my math really quickly. Negative 6 times positive 2 is negative 12, and negative 6 plus negative 2 is negative 4. The denominator, that's a difference of perfect squares. Now that we have completely factored everything, we see that those cancel, leaving you with your final answer, x minus 6 over x minus 2. Example 3. The numerator here, that's also a difference of perfect squares. And the denominator cannot be factored. Those matching factors cancel, leaving us with our final answer for example 3 of x plus 1. We have not seen an example like 4 in a while. The numerator, that's a difference of perfect cubes. So set up 2 separate parentheses, and then this is where you want to apply that acronym SOAP, which stands for same, opposite, always positive. You need your first sign to be the same as the given problem, opposite of the given problem, and then always positive. To fill in this blank, you take the cube root of the very first term, and the cube root of x cubed is x. To fill in this blank, you take the cube root of the last term, and the cube root of 8 is 2. To fill in this blank here, you're going to take whatever this term is and square it. To fill in this blank, whatever these two terms are, multiply them. And whatever this blank, whatever this is, this term, to fill in this space, square this term. 2 squared is 4. This right here will not be factorable. Now let's take a look at the denominator. If I factor this, that's going to factor 2. X minus 2 times x plus 4. Those x minus 2's are going to cancel, and now you have your final answer for number 4. Example 5. What I'm going to do to begin solving this problem is I'm going to multiply numerator times numerator first. So 3 times 2, that's 6. X squared times x is x cubed. Remember, you add the exponents whenever you're multiplying. And then y squared is going to remain y squared for now. Okay. Now, denominator times denominator. 4 times 3, that's 12. And then the x to the 4th power and the y to the 4th power will also remain the same for now, at least in the denominator. Okay, now let's reduce. If it was just 6 over 12, well, that would reduce to 1 over 2. Now let's reduce the x's. X cubed over x to the fourth will reduce to just x in the denominator. Y squared over y to the fourth would reduce to y squared in the denominator. And now you have your final answer for example 5. Example 6, I'm going to go about this one the same way I started example 5. I'm just going to multiply my numerators first. 2 times 3, 6, x cubed times x squared. That would be x to the 6th. Remember, add the exponents. And now y times y squared, y cubed. Now let's multiply the denominators together. I'm going to do my coefficients first. Looks like I have a coefficient of 2 and 8. 2 times 8, that's 16. And now let's do our variables. Starting with the x's. X to the 5th times x to the 4th. That's x to the 9th. Y squared times y, that's y cubed. And now let's begin simplifying. 6 over 16. Well, both of those numbers are divisible by 2, so let's reduce them both by 2. All right, now let's simplify our x's. X to the 6th over x to the 9th. That would simplify to just x cubed left in your denominator. Y cubed over y cubed. Those cancel one another out. And now you have your final answer. Example 7, we have x minus 2, which cannot be factored any further, over x plus 1 times, now my numerator here, 3x plus 3. We can factor out of 3, so I'm going to go ahead and do that. That would leave us with x plus 1 over, and in the denominator here, we can factor out of 5. And if we did that, that would leave us with x minus 2. Okay, now what we're going to do here is we're going to see, do we have matching factors that cancel out? And we do. X minus 2 cross cancels with x minus 2. X plus 1 cross cancels with x plus 1. And now at this point, look to see what is the only thing that is remaining. That would be 3 over 5. And that's your final answer for example 7, 3 over 5. Example 8, the very first fraction is fully factored. X minus 3 over 2x plus 1 times the numerator here, we can factor out of 3, leaving us with 2x plus 1. And the denominator, that is a difference of perfect squares. That factors to x minus 3 times x plus 3. And now let's start canceling any matching factors. X minus 3, those cross cancel. 2x plus 1, those cross cancel. What's left over? Looks like 3 and x plus 3. And now we have our final answer. 3 over x plus 3. As long as you're good at factoring, hopefully you're aware that this really isn't too difficult. Example 9. Looks like in the numerator here, we have another difference of perfect squares. Perfect cubes. That's what I meant to say. Difference of perfect cubes. Same, opposite, always positive. All right, the cube root of x cubed is x. The cube root of 125 is 5. We're going to take this term and square it, put it right there. We're going to multiply these two terms, put that there, and we're going to square whatever that term is. Put it there, and then remember, this is not going to be factorable if you're doing a difference or sum of perfect cubes. Now, the denominator here, that's going to factor to x plus 7 times x plus 2. All right. this fraction, that numerator is going to factor to x plus 4 times x plus 2. And now this denominator here is going to factor to x plus 4 times x minus 5. And now we can begin to see what factors are going to cancel out. I have a pair of x minus 5s that are going to cross cancel. X plus 2s that cross cancel. X plus 4 over x plus 4 that cross cancel. And now we know what our final answer is going to look like. Your final answer is x squared plus 5x plus 25 over x plus 7. For example 10, notice we're not multiplying fractions, we're dividing fractions. And this is where you want to employ keep, change, flip. We want to keep the first fraction the same, but of course, if there's anything that you can factor, factor. So I'm going to change this to 9x times x over, now in the denominator, we could factor out a 3, leaving us with 2x minus 1. So keep, we kept the first fraction the same, we just factored it. Next, change. You want to change from division to multiplication, and now flip. You want to take whatever the second fraction is and flip it. 2x squared minus x over 3x squared minus 12x. Now what I need to do is I need to now factor that second fraction here. So let me copy down my work from the first fraction. And let's see, over here, 2x squared minus x, we can factor out an x, leaving us with 2x minus 1. In the denominator here, we can factor out 3x, leaving us with, looks like x minus 4. 3x, yeah. All right, now let's see what can cancel out. All right, looks like we have a pair of 2x minus 1s that are going to cross cancel. Looks like we have x's that will cross cancel. And there's a little bit more simplifying that I can do here, but I'm going to wait and do that in just a second to hopefully keep it a little bit easier. I'm now going to multiply numerator times numerator. So 9 times x times x. Well, there's nothing remaining here. So 9x squared over, and now I'm going to multiply denominator times denominator. 3 times 3. And we're left with the factor x minus 4. Now, hopefully you can see those 9s are going to cross cancel, leaving you with our final answer of x squared over x minus 4. Example 11. The very first fraction, nothing can be factored. In the denominator of the very first fraction, we can factor out 2x, leaving us with x squared minus 1. Now, since we're doing division here of these two fractions, I'm going to do keep, change, flip. So let me change from division to multiplication. And if I flip this fraction here, x was on the top, now it's on the bottom, and I'm going to factor this binomial and put my result here. So I can factor out 2x squared, and that would leave me with x minus 1. Okay, let's see. What can we cancel? Oh, you know what I missed? That can be factored a little bit more, can it? We're dealing with the difference of perfect squares. X squared minus 1 factors to x minus 1 times x plus 1. Okay, now let's see what can be factored or canceled. The x minus 1's cancel. And x squared over x, that would leave us with no x in the denominator there and just one x in the numerator there. Now that I've done that, look at this. 2x, 2x. Those cross cancel. Let's see, what are we left with? Looks like in the numerator, the only thing that is remaining is 3x minus 1. Over. And in our denominator, it looks like the only thing that is remaining is x plus 1. And now we have our final answer for example 11. Example 12. If we factor the first fraction, the numerator would factor 2 x plus 2 times x plus 2 over x plus 3. This is a division problem, so we need to do keep, change, flip. I'm going to change to multiplication. And x plus 2, I could put it over 1. That's going to help me realize what my problem is going to look like whenever I flip it. 1 is now on the top. X plus 2 is now on the bottom. X plus 2's cancel. I'm still left with 1. X plus 2 times 1 is x plus 2 over the only thing remaining in the denominator is x plus 3. That's your final answer. Example 13, x squared minus 1. That's a difference of perfect squares. So x minus 1 times x plus 1 divided by, so let's change that to multiplication, and let's take this fraction and flip it. X plus 5 is now on the top. X minus 1 is now on the bottom. Those cancel, leaving us with just x plus 1 times x plus 5. And you can leave your answer just like that. Example 14, here's what we have. We have 6 over x minus 1 divided by 3 over x. This is another way you could write example 14. So now we can do keep, change, flip. Keep, change, flip. So if you multiplied these two together, 6 times x is just 6x over 3 times x minus 1 is 3 times x minus 1. And now we can divide here. 6 divided by 3, that's going to leave us with 2x in the numerator and just x minus 1 in the denominator. Your assignment for today is on delta math. Get started.